So the next one is called a test of homogeneity. And a test of homogeneity tests the claim that different populations have the same proportions. And actually, I think I want to do my highlighting on that one. And again, this is called a test of homogeneity. I want you to think of the word homogeneous. Homogeneous means the same. So you're saying when you're doing a test of homogeneity, the results with the rows and the columns are pretty much the same, which is saying they're equal, which is saying independent. So that's why the tests are done the same way. The wording may be different. This one's harder to recognize. It'll have the word same or the word different usually in it. Independent, dependent stands out more. So sometimes with this one, you have to watch for it a little bit more in that your brain will say, oh, I have a table. And then you think, well, maybe it's independence or homogeneity. And when you see that word same or different, that would tell you that it's a test of homogeneity. I have here that it is the same method of entry in the calculator. The only difference is the wording of the hypotheses statements, plural, and the conclusion. So you're not going to have the word independent in there. You're going to have the word same and different in there. You can see when you look at how to enter it in your calculator. Doesn't want to do it. I guess I have to highlight a word. When you're entering it here, it's exactly the same. Entering the data in the matrix and then doing your chi-square test. So the type of test, the way you enter it in the calculator is exactly the same. Okay, let's look at this example. Oh, I should have written example. I should have example typed here, huh? So this is example 2. The table summarizes data for a sample of women. Use a 0.01 significance level. So alpha is 0.01, so a pretty significant level. Test the claim that proportions of agree or disagree responses are the same for the subjects. Oops, I didn't want all that. Are the same for subjects interviewed by men and interviewed by women. The proportions of agree or disagree are the same for subjects interviewed by men and women. And then it says, does it appear that the gender of the interviewer affected the responses of women? So when I look at this, let's look at what our variables are first. Here's our rows. And in the rows, we have women who agreed and women who disagreed. Here are our columns. And in the columns, we will have male, if they were interviewed by a male, or if they were interviewed by a female. When I look at this problem, I always wonder, like my mind says, well, I wonder what the question was. To me, that would make a difference. So whenever I see a study, my brain always says, well, what about this? And what about this? Like, what were they interviewing them about? And another reason I think about this with this problem, I always share this story. Years and years ago, I grew up in Pittsburgh. I was shopping at Rayleigh's in Pittsburgh, and which has since closed. They asked me if I would take a survey for them. And it was a survey about bras. And it was right outside the grocery store. And they had different bras. And you had to look at them and say which ones you liked and which ones you didn't like. Well, if you think about it in the context of this problem, If there was a male interviewing me, that would probably be pretty embarrassing. It was a female. But depending on the topic, this can make a big difference, whether it's a male person or a male interviewer or a female interviewer. To me, the topic would also be kind of a lurking variable here. So we're going to see if this makes a difference. When we write our hypothesis statements, our claim says the proportions of agree or disagree are the same. Well, the same means equal. So the claim is going to be in our HO, and we're going to say proportions are the same. Oops. You could also even say frequencies are the same, because how many are in each section, each cell of your matrix are the same. Proportions are the same. And then down here, we could say proportions are different, but what we're going to say is at least one differs. Right now, it probably would just be they're different. But if you had more categories, if you had more columns, or if you had more rows, you would not be saying they're all different. You would just need to say they're not all the same. So typically here, we just say at least one differs. Claim goes up here. And again, you could say proportions here. You could say frequencies are the same. You could say proportions of agree and disagree responses are the same. You could take it verbatim from the example. So here, sometimes, again, it bothers students because it's in words, it's not in symbols. But what's kind of nice about it, again, you can put those words, you can put that verbiage in the margins of your stats formula packet by the contingency table section, which is on page 3. And that way, it'll refresh your memory on what it looks like. Now, we're going to put the data in the matrix, and then we're going to do a chi-square test. So I want to do it again in the calculator so we get some more practice. So I have the calculator here, and I carried over the material from the notes. We're going to enter the data, enter data in matrix. And what will probably happen is the first few times you might need to look at your notes. After you've looked at them a few times, you usually don't need to. Again, though, you can use your formula packet, which actually has it in there, but you can put some notes on your formula packet. That's fine. And then we're going to do our chi-square test. Okay, so we're going to go to matrix, so second matrix. You can see that the matrix I entered in the last one is still here, and then the expected matrix that the calculator made up is there as well. I'm just going to write over it. We still have 2 rows and 2 columns. So this is a 2 by 2 matrix, rows and columns. So the 2 by 2 can stay in there. And you can either press enter or you can arrow around. And then I'm just going to write over what's in there. Okay. So the data's in there. We're ready to do our chi-square test. Over to the tests, and I can scroll up. Chi-square test. The observed, the expected. Calculator does it all. And our results, our test statistic, it's a chi-square, 51.46, and very tiny p-value, 7.31 times 10 to the negative 13th. super tiny. So this is definitely less than 0.01, which is our alpha. So we're going to reject HL. If the p-value is less than alpha, we reject. So we're rejecting that. The proportions aren't the same. At least one differs. And the claim was up here. I forgot to write that. So here we would say, if we're writing it formally, warrants rejection of claim. Here's what that means, though. At least one differs. They're not the same. It made a difference whether you were interviewed by a male or a female. It made a difference whether they said agree or disagree. Now, there's a question on this one. It says, does it appear that the gender of the interviewer affected the responses of the women? Well, we just said the proportions weren't the same. So did they affect the responses? Yes. The gender of the interviewer affected the responses. Oops. So again, when you're doing these, you're just saying, is this happening or is this happening? Now that we've been working on these for a while now with hypothesis testing, you can shortcut it and either just say, oh yes, proportions are the same, or at least one differs. You don't have to do this formal part. While we're here at the calculator, I just wanted to show you if you had a matrix that was a different size, how that would work. Because I realized both of these happen to turn out 2 by 2s. So I just want to show you what that looks like. And again, if you have the 83 and you're doing a larger matrix, it might go over the screen. It might go outside the window, but then when you use your arrows, you could see it. So let's say I had, and I'm just going to make one up here, like a 3 by 3. So I'm going to have 3 rows, and I'm just going to put, you know, whatever numbers in here. Okay, that's not a negative, that's just a 4. Okay, so you can see this would have 1, 2, 3 rows and 1, 2, 3 columns. Why am I having such a hard time spelling columns today? Okay, so it's a 3 by 3 matrix. We're going to go over to edit. We're going to make it a 3 by 3 matrix. Now, do you see it's all ready to go? And we would just put in the values. Okay. It works just the same way. Most of them will be 2 by 2s, but there are times that you might have an extra row or an extra column. Okay, let me just carry this over to the notes sheet. I like to end it on that note. Okay, so I just wanted to make sure you got everything carried over onto the notes sheet. So on this one, again, we rejected, which means this is not happening, which tells us at least one differs, or it warrants rejection of the claim that they're the same. That implies that gender of the interviewer affects the responses. Okay, we did not support the claim. We rejected the claim. Okay, So I know we only did 2 examples, but I think you're going to find these go pretty smoothly. And I would consider when you're doing your project, when you're setting things up, they tend to lend themselves pretty well if you can to the projects if you can put your data into tables. So something you may want to consider. Have a good rest of your day.